you need to yeah, every time we start, we need to start here. So just click here and let's install the Gmap library. Start working. It's so slow. Okay, so let's go to the next step. Open Map with Gmap library to install the Gmap, install the Earth engine, to import. Then to do the authentication. So we need to go to click this link to get the token. Generate a token. Send the email. And then continue. Check both this. Then continue. And click this to copy the token. Then back to here. Paste to here. Hit the enter. So successfully save authorization token. And we do the initialization. And show the map. Okay. That is every time we need to start this. Then we can try different places. I think last time we tried Concepción and use the zoom 10. You can change the zoom to any so large or smaller. So if you want to make it zoom more, you can change to 13 to see how we. Okay, Concepción is so big. Okay. Then yeah. Okay. So is everybody already get to here? Any problem? No problem, right? No problem. Oh, so is that works okay? Go back. We share this. Yes. Okay. Okay. Maybe we do. So you what? How about yours? Okay. So. Yeah. Success. So if you let me see. Yeah, you should have something like a successfully installed. Over this which yeah, you use for that. Issue. Educate, that's very good. What's this? Yeah. See, if it's successful, I think we should have successfully installed. See that just stuff there, you know, you still don't see that. Is to connect the package, successful building exchange. Yeah, yeah. Try a lot of okay, so Australia is not successful. I don't know why, but we'll continue. Load the image. So here we'll load a single band image, which is the DM. Okay. So how you know where is the data? So is you can always go to the Google Earth Engine data set. For example, here SRTM is part of the Google Earth Engine data set. So you come here, then there's view all the data sets here, and then you find so Landsat, Modi, Sentinel, all of different type of data. Okay, so this is the SRTM data set. SRTM data set. So this is you can just copy this this one. This will be the image the data ID. Okay, so you can copy this data ID to put here. And so that is where you get the data ID from. So you can easily get another one, for example, Landsat. If you want to get the Landsat, pick a Landsat, then you will click Landsat selection 2. Then you will find the, for example, the level 1 data, level 2 data, or analyst ready data. For example, you want to use analyst ready data. You click this, then you will continue access the file. Then description is the connection. Information. ID. And issue for active issue goes with. Oh, this comes to the USGS already, so it already go out of the Google's data connection. So I don't know where. Okay, let's click here. Yeah, it's okay. Still in Google's engine category, then surface reflectance. Click this one. Yeah, okay. So you can see this is the ID, Google's engine ID. So this is where if you want to use the Landsat data, which you copy this and paste to here. Okay. So right now we look at this SRTM data. So then we call the add layer to the map. Then put it to the map. So skip. So this is the voila. This is the DA. On here you can zoom to large because we don't have a scale. We don't have a wide scale. So we need to make a large scale. But right now we don't have a wide scale, so that's why you don't see that clearly. But if you zoom out, you will see. Yeah, this is the DM already here. Okay, so the next step here is we use some parameters. Okay, so we set the visualization parameter as a dictionary. Okay, yesterday we talked about the dictionaries, right? So dictionary we will have a curly bracket, So we set the minimum, maximum, and also color scale. Okay, and then this is the parameters. So we add a layer DM with parameters. Okay, and then we put this SD visualization, then map. So let's do execute again. So this time you will see the DM with different with outstanding contrast, right? Contrast. So you can change this code. So you need to find a little more if you want to change other code. Then so this is the color code underneath. So if you want to see use other code, so you click here, then you will find different code scale and more detail. Okay. So we are not going to go detail on this, but you should be able to find the details if you want. So go back to here, multi-value image. So that one is a one-value image. So right now we go to the multi-band imaging. I think I already went to there. The Landsat 8 surface reflectance tier 2 data. So if you go to here, that's what the imaging image ID is here. So you can copy here. Then we copy, we paste it here. So it's already here right now. We just use this one. Then we can put the image in the center. This is called put the image in the center and zoom to 8 zoom scale as 8 or as 10 as 30. So you can change. Then the parameter you have you scan 4, band 3, band 2, which is a 2-color composition. The scale is from 0 to maximum 1000. Opposite is 1. Then add layer. So this is the add layer, the image, parameter, and also the name, the title. Okay. So let's do it running. Then you will see the image cover of this this model. Yeah. So anyway, get to here. What's wrong? Oh, I saw you want yesterday. You just log in. Oh, you got it.
Okay, but I only miss the wording the code of the answer.
Okay, yeah.
I
So-
use the then
Yeah, so if you go here, so this is all of the data. So we have all of the data. So that's why where you find the data. So then you can find different type of data available in here. Yeah. So then all different type of data. This is Sentinel-2, Sentinel-1.
and them.
Yeah, TN, SRT, yeah, you can search from here. SRT, here, then you can find which SRT. Yeah, this is SRT. So this is the ID. That's really important. So you can easily find here. Yeah. So let's say which is the one you just use it for this one. Yeah, it's still here. So here one, two, this one. Yeah. Okay. Okay. So once we get this one, then we can continue. Imaging method is a 2-color imaging. You can change the color composition. For example, band 3, 4, 2. Okay. Because then for the Landsat 8, band 432 is a 2-color. Band 432 is 2-color. Band 342 or any other composition will be 4th color. So we just change this. Then 3, 4, 2. So the minimum is 0, maximum 300, 3000. Then the parameter is the same parameter we defined before. And then the title is 4th color image. So where's the 4th the title? Where's the title? Okay, let's do that. Let's do that. See where the title is. So this is the 4th color imaging. Yeah, I didn't see the title. What's the title? Didn't go good. Finish, cancel. Yeah, I don't know where is this land force color, this title. Let me see if you know. Oh, not here. That's okay. You guys is able to find where is this land and force color? Where's that? That's the title. It will be somewhere. You want to find it or in the map? Or, yeah, I didn't see that in the map. Yeah, here you can see. But yeah, don't worry. I think that is not that important. It should be shown somewhere. Okay, so yeah, we. I think I can ask the student later. They, we can make a lot of composition. Yeah, so this one is use the vegetation as the real bank. So vegetation bank, I think is band 5. Okay, so it's a real influence. So if we put a real influence in the real bank, we will see the vegetation as real. Okay. Yeah, you can try different composition to do. So let's try put the fee.
If you go to the
Oh, just okay. It's here. The name is here. Okay, the name is here. Then say false color. Yeah, that's right. You're correct. So yeah, so so where to get this one is this is the tool. You can actually know what kind of layers here, so you can take this off, or add this in, okay. So you can check this one all in, all off, okay, and yeah, that's good. Then for set false color, if you want to change this one will be changed here. So while I want to change the color composition again. For example, this is I put a 3 here, 5 here, which is the vegetation become 3. Okay, 4. Then I do it again. The vegetation will be green. You see, there's lots of green, which means vegetation. There's lots of vegetation there. Okay, and you can change the title also if you want to change this. Yeah, this is the false color with which is vegetation as green. Okay, let's do it again. And then if you click this one, yeah, then you will see the legend here. Of course, this is too many, so that's why you should. But if you put your mouse here, you will see lens and false color with vegetation screen. Okay, yeah, good. Okay, let's continue. Yeah, image property. So we can also get image property. You can also click here to get the property there, but you can directly call image property. Okay, so image, call this image ID. I think we already have, and then the prop, you go to the image prop, then the prop get information. So this is the image information, the metadata for this image. So, for example, cloud cover for this image is 0.06, which is very good image and really good cloud cover. I think this should be percentage, right? Percentage 6% or 0.6%. Actually, I don't know this. Then land cover, cloud cover on land is 0.1. Earth sun distance 0.99. So virtual geometric RMS model X total and the X direction, the Y direction, and the image date 2014, March 18. Okay, image quality 9 for the optical image, for the thermal image 9. Okay, Landsat ID, which is the ID, the product is level 1. Luminous scale is 30 meter pixel size. There's lots of information you can get from here. Sensing time is March 18 in the 18 hour 6 minutes second. Okay. Solar azimuth angle, solar zenith angle, and application version and WRS pass. Okay, so pass and roll, which is every laser imaging have a pass and roll, and as size, the size of the image. Okay, I have 540 megabyte, and this is the band name for band 1, band 2, band 3, band 10, band 11, then aerosol band and pixel QA red set QA. I don't know what is this. Sys ID, okay, system index. Engine time, starting time, okay, all of this information. So you just use this to get info, get info. Okay. Then get a band names. Okay, so you can get a band names because the information is always there, but you can also get the band name from use this function called band name equal image band name. Okay. Print band name, get info. Okay. So very simple line of code. You don't need to remember, just copy, paste for future use. Then the projection, to get the projection information, then print the projection information. So type of projection. Then 30, whatever the projection information. Then cloud is information, get the cloud cover. Okay, this cloud information is 0.06. So I don't know if this is 0.06 or 0.06%. I'm not sure. Then this is the day of the imaging, so it's already 2014 March 18. Okay, so this is, you can get individual information, or you can get all of the information together. Use this. Okay, you just use this all of the information together. Yeah, and this is do yourself. Then we can get the Sentinel-2. So click here to get the Sentinel-2 images. To find the ID. Okay, I don't know why I didn't see that. We can come here, Sentinel. Sentinel-2. Yeah, click here. Sentinel, we can get the surface reflectance or the top of atmosphere reflectance. So then this is ID. You can copy, then paste to here. Yeah, so you can, we can just replace this one, or you can. So this is a different data set actually. So this is a different data set. So if I go back, so we know. Okay, I just use this one. That's okay. We just use this Sentinel-2. Then run this one. Yeah, I get a different data set. That's for Sentinel. So take a while, right? It's still running. Is you guys have any problem?
You change the source. So I think you need to select an image because that's that's the image collection.
Yeah, image collection. Oh, this is the image collection. Oh,
the code collection.
oh, that's right. That's right. This is the entire collection.
Yeah, you need to find the
How why one image? Yes, that's right. Okay. So oh, I okay. I can reload to give that one image. Reload. Oh, it's already a fake with one image. I think I can copy the ID here.
Yeah.
Is this the ID?
I think if you go.
Right ID this one? This is not the right ID.
It is, yeah, it's a bit different.
They're a bit different.
Let's see. Smart. When I load the original image,
Taking the system ID.
We will automatically actually save. But that's okay. I think let me try it if this works. Yeah, it works. Okay, let me see. Okay. Yeah, I think that's that doesn't work. Yeah, you need to get a one image. Yeah, but this is the image connection. That's fine. I think it should be similar. You get the lens that here. I don't know how to get a one. Oh, e.image. Okay, e.image. e.image, not e.image.
You need to the source folder for the name. So radius you click on the dot over there, click on the root spectrum instrument QA, it will give you the there, it will give you the folder.
Yeah.
This is what happened.
So always, okay, let me see, I think I probably here. Yeah, always get a long.
Right.
Think so. But that's fine. Is you guys works for you guys? Yeah. Okay, so his image is can you copy this to the you can do that? Yeah. Copy this to the chat. Then I can yeah, that's yeah, but this is the one. What is the chat? Yeah. Try to find that. Okay, let me get that on the chat.
You didn't show up?
Yeah, I didn't show up. Okay. You probably sing. Okay, see.
Yeah, copy.
Okay. Yes, yes.
She's connecting with the other room.
Okay. Okay. Let's do it again. Okay. Go up. Okay. One this. Yeah. Okay. Here's the property. So this is a Sentinel-2 multi-spectral images. So the process baseline, a process ID. This is different. Oh, actually, this is only the first part. Oh, no, exactly. Yeah, you not exactly same. There's a little bit difference, some here there. Yeah. So then, solar radiation, M1 and 10, 11, 12, B2, B3. Okay, so there's more than mentioned 8, the bands. There's okay, all of this information. Okay, anyway, so I think this is we finished the first finish this number 3 filtering. Okay. Any question? You finished that? You get it to it? Yeah, you finished.
And only the final part.
All right.
This I don't know. I am not in the shadow.
Oh. Okay. So let's see. Let's see.
Ahí,
¿Listo?
ajá. Como lo miren, la única que aparece. La voy a mandar por-
How about you? You want? Oh, okay. Good. You guys also work. More. Okay, I think you're eyeing. Oh, yeah.
Ya, bueno, sí,
Okay, good. I think let's go to the number 4. Okay,
number 4.
number 4. Let's go to the number 4.
So check your internet. Something that
I'm
worry about. Check your. See join.
Yeah.
We're connected.
Yeah,
Right. Yeah. So it's just a browser.
Okay, let's go to the number 4. Copy. So this is the image collection. I think before that we just show individual image. So here we will do the image connection. Okay, what is the image collection? Is a stack or a sequence of images. So is from a time series, as long as the data is collected from the satellite and also connected in the Google Earth engine. Okay. The image collection can be loaded by passing a GE ACID ID. I think we already tried an image collection of Sentinel-2 data into there. Little bit before. Okay. So in the data category, we can find the ID of image collection, but in this tutorial, you will be able to know how to handle this image collection by temporal information. You can use different fields like the time, the day, and the spatial area you want, and the metadata. So, so you can also go to here, which image connection. I think we already there before. So this is the way you always get different images connections from here. Okay. So this here objective is how image collection is constructed, or explore how then using the field function to get image collection of images, then visualize the image connections. Okay, so that's what we will do. So voila, as we said before, every time we start, we need to install the GE map library again, as long as we start a new section of this code, okay, because this is a different section of code. Let's go to the aim here. Once it's finished, successfully installed, then we can go to the next step. Okay, so I see here successfully installed. Then we can go to the next step. Import image library, which is Google Engine map and then Google Engine, then do the authentication again. So then go to here, okay, the token. So this is a little bit tedious, but I think that's necessary every time you need to do that. Here. Here. Continue. This goes. Continue. Then copy. Click on this one. Then back. Paste here. Yes. 8. Okay, successfully saved. Then do initialization. Then okay, so this is the first image collection of the Landsat 8. So image, so individual image we don't have the connection. So in the exercise 3 we don't have the connection. So here we have the connection means all of the Landsat 8 data. Okay. So if we run this one, then we will see how many images, Landsat images for the globally, how many images they have. Okay, so you will find that actually have 1.2 million images in this Landsat image collection in the end. For the Verano, we didn't use daily field media. So take a while, little bit of while to get all of the data. Yeah, so 1.2 million images. So, but we don't need all of them, is right? So then we can do the filtering. So the next one actually is to find the ICESAT-2 image collection, because I think I already did in the last exercise. This is what I put it here, so you can go copy that before we found that copy, but it's already here. So let's see how many ICESAT-2 images. ICESAT-2 image actually more than Landsat images is 1.6. Oh, it's actually 16 million. 16 million. So ICESAT-2 image, even though much less time connected, because I think ICESAT-2 is 2000. I don't know, the recently, but ICESAT-2 get lots of data in like 6 days or 3 days. They ICESAT-2 have the A and the B satellite, so they get lots of data compared to Landsat. Even though Landsat is the longest time series since 1985, but Sentinel has 2 satellites in the series, ICESAT-2. So there's lots of data. So if we this one, so you will see this will be 16 million. this is a much bigger collection, so it take even longer. So you can see it's so powerful. You don't use any of your resources, just couple of code. That you can access the Google EEG to get all of the information there and take any image you want for processing. Yeah, so this ID, image collection ID, I think we find it before we can come here, take a look how to find that. Sentinel-2, Sentinel, okay, this is the Sentinel, click here. Then we have the Sentinel-1, Sentinel-2. So this is the Sentinel-2 more spectrum. Okay, you see, since 2015. So Sentinel-2 is very recent.
I have a question on Sentinel. So the database we're using is the harmonized,
Harmonized.
the one that for
Oh, let me
is
see.
that a particular
Harmonized, okay. They have different version or different level. This, for example, this is the surface reflectance system to check. So you see, it's, yeah. So this is the also called harmonized. So this is the same ID as we used this thing. Hopkins, S2 SI harmonized. Obviously, SI harmonized, yeah. So why is harmonized? I think there's information here. We can you can get for description. The harmonized connection shifts data in newer version seems to be in the same range as in older C. Okay, so that's what that is why.
they are harmonized with all the data.
Yeah, yeah. So Sentinel-2 is a wide swath, high resolution, more spectral information support. Public's land monitoring study include monitoring vegetation, soil, water, as well as inland water and coast area. Yeah, so there's lots of information here. You can check, and they also have some code here. You can copy paste if you want to learn more. This is the reflectance. Yeah, different level, different fraction. Let's go back here. See, oh, it's here. Not finished yet. So in the meantime, if you're interested to add a code or add a text, so that's what you can do that. If you want to bring them other information, for example. This, yeah, for example, we want to add a text here. Just click here, add a text, just for a test. Just for the test. Yeah, it's here, just for a test. If you don't want that anymore, you just select this. So it's a very easy platform, and still working. Wow.
Mine ended.
You finished it?
Like, it took like 7 minutes, so you have to wait.
Okay.
I think it's for the internet connection.
Maybe, yeah. Is anybody finished? Nobody?
No.
Okay. Yeah, we don't need to, I think we can look at this. So field by day. So this is Landsat images. So if we put a field date, okay, 2020, January 1st to 2020, December 31st. Okay, so we only look at 1 year of data. Then you can see how much data. So let's do that here. Probably it's still, this is let's stop that. You want to stop that? Or let's continue.
Guys, stop it, because like, the collection is pretty loaded.
Okay, let me stop that. I don't want to. Because last time I did that, this is really much more data. Yeah, it's 60 million, 60 million. So even don't want to stop. But oh, finally finished.
Yeah.
It, 60 million. Yeah. So it's like it's like 16 times Landsat data. Even Landsat data was the longest. Is the longest. But Sentinel-2 we have much more data set. Okay. So then this is the Landsat we fill data with only to 1 year. So let's do that. Finish and print how many data, how many image. You will see the 1 year is only 140,000. 140,000. Okay. Then we can fill with location. Okay. Fill with location. So in that time period, then we will also fill with a region of interest. So region of interest is the called the fact geometry, line of string. Okay, so you have the four column of the area. Okay, so how you define your region of interest? You have different way to define. Okay, so if we could click here, we will see there's a different way to define region of interest. You can define like a polygon, a rectangular, a linear ring. So let me see if we can actually define that as because all of this polygon is a regular polygon. Can you directly input like a polygon created before? I don't think there's an example here, maybe not. So Jam, you cannot directly input your shapefile. See, you still either use this function, or this function. Okay. In this case, in our case, we use this function. So lower left, up left, up right, up left. I think. Lower right. So I think that's the direction, but maybe wrong. We can just define that. So the four column. Then let's write this. Then now you have filled the image collection in this boundary, and also the day. So we can run out with this month of data or this year of data and this region of interest. Okay. Then how many data? How many image here? Is 1,800. Perfect. So you can easily change to half a year. Let's see. June 31st. See how many days. Should be half. 900. Oh. Why this here? Add data type. Oh, there's no June 30, maybe 31st. Let's see. Yeah, there's no June 31st, only June 30. Okay, so yeah, half of the data. Okay, then this loads the map and loads the first image because we have 940 images. Let's load the connection, the first image. Okay, you can. Of course, you can load other images. So this is just okay. Load the first image, and the parameter of the image is minimum value 0, maximum 2000, band use band 5, 4, 3. This fourth color, and common 1.5. I don't know what this is a dictionary, right? So this is color ranking. So it's a dictionary. So there's 4 keywords. Add a layer, and also this is the first image. Okay, the size of the scale is 8. You can change to any scale. Okay, so let's do the slope. Yeah. So this is the image in Tanzania. So yeah, I think if you click here, we will see the layers. Yeah, first image, which is our title of the image. First image. So because this area is low vegetation, that's why vegetation Tanzania probably is a desert area. Okay, we can try the 2-color image. 4, 3, 2. Okay, try that. Yeah, this is the 2-color image. Oh, there's lots of cloud. The 2-color image show you have lots of cloud. Under there's some vegetation. So right now we want to see what is the cloud color because I see there's lots of cloud. So here I tell you the property of the image is 49%. Yeah, so I think it's a percentage. The last one is 46%. So this one you can see 49% of the cloud cover. The land on the land is also 49%. So means this area there's no ocean. The entire area is in the land. And okay, so all of the information. Okay, so we can also filter by metadata. One example here is show you use the cloud cover. How much the cloud cover? Yeah. So for example, 32% is covered by cloud. Usually we want the image is less than 10% cloud cover. Okay. So there, this is the example field data. Use this time period, the boundary, we use the point, which is the center of that point, get an image with the center of that area, and the field metadata, we use the cloud cover as our field, then less than 10. Okay, cloud cover less than 10. Then also sort. Last time we said we can also use the reverse sort. Right? So it's sort with cloud cover from less to high. Okay, from smaller to high. Then do it again to see how many. Oh, okay, so totally 940. Wow. Okay, then. Oh, I think because I didn't run this one yet, that's why he still used the original. Because I don't think there's 940 image with cloud cover less than 10, which is impossible. So voila, rerun again. Yeah, 6. Okay, only 6. Because if I don't rerun this, so the connection is still the connection, the previous connection. Yeah, the previous connection we had here, we changed 940. Okay. So out here we use the cloud cover as our connection, and we also probably use different place because this is different location. Can easily use our area Concepción. Yeah, then we load that image onto the global map to see where it is. Oh, back to California. Okay. Back to California here. Okay, so this is in California. So you can see then right now we get the information. The cloud cover, the first image, cloud cover is 0.07%. The land is 0.1%. Okay, so this is really good clean images. So the question, what is the cloud cover for the first image, which is the one we already give? 0.07%. Basically clean. Basically clean. Low cloud. Very. So you can also extract the information of the image in the image collection as a form of array, as the aggregated array function. So right now, because we said, okay, get all of the image with image cloud cover less than 6%. So what are these 6 images, which is this one? Okay, collection, aggregate, array, cloud cover, get information. So you they sold from less cloud cover to high cloud cover. So the first one is 0.07, second one 0.06. So we can run here. It's because this was I run before. Yeah. The third one, fourth one, sixth one, seventh one. The sixth one. The sixth one is 6.5%. And also we can get the image ID. Image ID. So run that, get the image ID. So you can get the image ID. One is okay, this is the October the 12th. This is the April the 3rd. This is the March the 2nd. This is November the 29th, October the 28th, and June of the 6th, which is from low cloud cover to high cloud cover. Okay. Yeah. So you can easily add a line here, or add some information here. Image array as cloud cover from the lowest to the highest. Okay. You can add any information here you want to just keep uniform. And then and from this image array, you can import the image you want from the image collection array ID. So ID from 0, 1, 2, 3, 5, 3, 4, 5. Okay. So every for the index for the Python is start from 0. 0 is the first image, 1 is the second image, right? So array ID is saved as a variable ID array collection, aggregate array, sister ID, get information. So import the third image, for example, the third image index is 2. Okay. So image import image array ID 4. Okay. So the third image should be 2. Okay. Array index should be 2. Okay. Index 2. So image visualization use a parameter from 0 to maximum, and the band composition, which we use the 2-color composition. Common, I don't know what is the parameter this is, so we should check what the common is here. Then add a layer, and so add the image to the map. Okay, let's do it. Yeah. So this is the image. This is the third image. Okay, the third image is cloud cover of 0.05. Let's do the sixth image. Okay, sixth image because we have 6% cloud cover, so we can change this to 5. The sixth image is index 5. Okay. Yeah, so this is the sixth image. You can see this cloud, lots of cloud. So the cloud cover is only 6.5%. Okay. Anybody already get here? Okay. Good. Okay. Good. Yeah. So we can also change the image composition. For example, let's do band 5. Band 5 is the real infrared, which is the vegetation. So vegetation should be red in this case. Yeah. So you can see there's lots of vegetation in this California. Yes. Okay. So do yourself. You can use the ICESAT-2. I think we already collected the information there. Okay. So let's go to Hongjie, which is my PhD student. Let's see, what's the time? We have time to go to the.
We still have an hour.
Okay, let's go to the number 5. Any question for the number 4? Huh? It's very straightforward, is right?
So
Yeah.
is there a way you are using the one of the big number 20? You're using a filter by the first image. So it's in the number.
Can you use the second image or third image?
Or the last one.
Yeah, the last image. Yes.
I usually get no, the first is the last.
Yeah.
How do you do that?
Yeah. I believe you can easily do that. Let me try. Use the last, or use the index. You see, this is where we can use the index. For example, the array. We can use the aggregation array, then use the index. That's why we can easily get the number 1, number 2, number 3. In this case here, But I know what it means in that in the up here, the first image. Here, the first image. So do we have a function called the last? A or
There is a last Python.
Can ID array. Select one.
Sorry, so you did,
Let me see, do we have the last?
no,
We don't have the last. Let me see. Yeah, looks like we don't have the last. Okay. Yeah, we don't have the 8. I think we need to see what the connection, the function under the connection, what kind of function we have. I'm not familiar with that, so image collection. So how we can find that? It's I know we can easily do that with array, is right? Array application use the image index, right? So this we can use this kind of information to put the image in the array. Then we can do that.
okay.
Yeah, but I don't know if the connection can do that. Let's see if Yong is here. Yong, are you here? Oh, he's not here. Okay. Yeah, we'll define that.
Yeah, so yeah, it does what it does, but at first, if you want to just, you cannot do it directly from the collection. You have to aggregate.
Yeah, yeah.
into an array.
Yes. But I guess the connection should have also a little bit flexibility, right? Let me try another one. For example, we say the second. Can we do the second? Where is that? Change to the second first. Okay, let's see. We can change to the second. Let's see if we can do that. No? So yeah, he only have the first, he don't have even the second.
Yes, so
Yeah, so this is a weird. It's only first. Oh, you see, this is only the first. Let's see if we have the second. Do we have second? Have select, save. We don't have that. You see. If I this so we need to do a little bit more if we want to do that. Yeah. Okay. Any other questions? Yeah, I can ask Yong when he's here.
yeah, it's possible with the method that Jan found, but it would be great to do it directly on the collection.
Yeah.
Have a look at the functions of the collection. That's only first.
Yeah.
That's not else. Okay. Yeah, if you really need to say you need to make it array, then you can use the index. Okay. Anyway, I think that's a good question, even though I cannot answer that. Okay, let's go to the time series. We can start a little bit and then once time is finished, then we can go quickly. So let's come to number. Stop over here. Okay. Here. So I want to delete the previous ones because if you open too many, then maybe will actually take lots of memory, maybe. So just delete the first two. So come to the number 5. Number 5 for time series. So because we say that we have lots of image connections, so we can use the connection to do a time series of animation, change detection, whatever. So I think this is what interesting, very interesting here. So by using multi-image provided by Google Engine, you can create a time lapse animation. You can see the temporal variation of value by time. In this tutorial, you will create a time-lapse animation to see the groups of urban area in Las Vegas. In addition, you will create a chart to see the temporal variation of the vegetation index value for a certain point of interest or region of interest. And finally, you will create a histograph of NDVR value for specific area. And I think we also have the urban heater island temperature done. So we end up with a few more examples here actually. Okay, so the same thing. Let's start with install the GMap library. Okay, take this beautifully. Then also import this information. You see, every time we insert the GE map and the EE. So this time we also import the OS operation system. Then also authentication. So they get the token. Generate token. Go here. Continue. Check both. Continue. Copy. Back here. Test. Okay, say initialization. Okay. So the same thing, we will define a region of interest. So I think we showed that how to define region of interest before that. So is basically here is also defining the polygon. The same thing we come here. Let's see if we can actually define. Yeah, so the ring find polygon from the ring I don't know if there's any way you can actually import a shape file. Jen, do you know this? I think that's what you like to do, right? But I don't see that. Maybe we can ask Young if he will be here in the afternoon. Yeah. It's like, yeah, is a rectangular or a square, whatever. Anyway, so I think I don't have an answer, but this is the four column. So start from here, then you back to here. So you need a four column start from here, then back to here. So that's why you have 5 points here. Yeah, left. Yeah, I think from here, go to here, then go to here, come down here, back to here. So 5 points. 4 points finally back to the region. Okay, this good. That's you guys. And import laser image for this region of interest. So we define this region of interest, the ROI. So this is the region of interest ROI. The start year 1984, end the year 2021. Okay, so you see it's like 40 years of data. 40 years of data. Come on, if you want to get 40 years data to your local computer, think how much time you can do that. But here is just a few clicks. A few clicks. You get 40 years of data and map. And you see they directly map to here and change. So how much, how good? Somebody zoom a little bit less, so we can see that much easier. See? Urban growth, Las Vegas, from 1984 to 2021. So this is the 4 column we define, and we can also. So here the vegetation is red. Okay. So so some parameter you can see the parameter we have the near infrared, red, and green, color 5. So each second how many images? 5. So if we put a 10 will be fast, right? So for example, we can do it, make it fast. So it's going much faster, right? So every second you have 10 images. Previously, every second we only have 5 images. And then we can change the others. The color. This is the color. For example, this color is changes white. Yeah, this phone color is white. We can change to let's say blue. And then the bar is blue. Where's the bar? Yeah, this blue is the bar. We can change the blue to red. Then is real inflated rate. So real inflated is in the rate. So we can put a real inflated to rate to the inflated. So we can change that to, for example, exchange this term, exchange this. We can kind of do exchange. Yeah, copy this. So then in this case, the vegetation will be green, or will be blue. Yeah. Okay, so let's do it again. Oh, my internet is not stable. Oh, this is what I didn't change. The bar become red. The word became blue, and the color composition vegetation became green. And you can add a little bit to just do the classification to get the area of the change. So there's lots of work you can do. So you can also look at the area of this lake. This lake area change from time to time. And of course, this lake is man control, but it's depending on the weather, right? Precipitation, also, even though it's controlled. Urban growth in which in Las Vegas, where is that word coming from? Yeah, so the label is here. You can change the label wherever you want. So it's very simple, very simple. How powerful. So you can change the scale, leave it smaller. Okay, anyway, I just so actually I ask you to change change okay, we ask you actually to do an example of San Antonio. We do a San Antonio, so this is San Antonio, the code. So this is San Antonio. Let's do the San Antonio. In this one, region of interest. Okay. Import Lancet. And I think I need to change this to San Antonio, right? So right now is already working. Try to create the time series for San Antonio. Okay, it's here. So San Antonio time series. Yeah, I just changed that label. It didn't respond. Didn't because it's already processed after before I changed that. So this This is San Antonio. So you can see San Antonio has lots of vegetation. So this composition has a band 5. Here infrared is not good. So we should use another composition to make it big. Not because too much vegetation there. It's all red. Okay. We can also save the image, the time series, so you can download it to your local and you can do a presentation, for example. So this is go back to Las Vegas, for example. Las Vegas, then get the image, how many image? Okay, so this is how many image? From 1985 2019, started from June 10, 8 of. Okay, yeah. Then how many is 35 inch collection? Then the name of the output and set images. Then define the parameters. Okay. Then create this image. You can download this image to your local computer. Make a video. Okay. Download the video. I don't know if you can show the image. Now we add text to the if image. There. Yeah, I didn't see the image actually.
Maybe for the maximum and minimum,
Maximum.
maybe video arguments.
Oh, yeah, from 0 to 0.4. This is, yeah, this is one. Then you go back. What is the number? What is the value before Las Vegas? We actually didn't assign that. In the point 4, I think this if this is the reflectance, we change to 0.8. This sure. Oh. So if you want to find where's your code, you go to your book, go to Drive. So you should have a folder called Colab Notebook. Okay. collect notebook will connect all of the copy you did, will store it here. I'm serious. I'm serious. This is the original file, and you see what the was there. Yeah, it's the same. It's the same. I 35 region of interest, time frame 5. Let me see what's the difference between this one and this one. The same is right. Yeah, I don't see the really difference. Yeah. So go back to before. 111. And so this is the same like the original one. I don't know why. Didn't show. The same. So I think we read for my student when in the afternoon. Check with him. Yeah, I don't see the any problem in the code. Is exactly like the original one.
Maybe one problem could be the order of execution of the code. But I'm not sure.
Yeah, okay, that's fine. I think we will leave this question here. I sent an email to the student and asked him to come in the next section. So so we will fix that before we start the next. Let's continue this one. Okay. Oh, this one we cannot do that because animation is not fixed. Okay. We can let's continue this part. Create a time series chart. You will create a chart to see the variation in DVI here. With those County, Northern California. So let's import, identify a 2-kilometer path along the region of interest. So the region of interest, you can define the 4 corner, or you define the central point. Then you can have a buffer of 2 kilometers to the central point. Then collect NDVI. So NDVI, you can use the image collection from the MODIS. Okay, so this is the MODIS image collection, NDVI, and the field data, which is 2010 to 2020, which is 10 years of data. Okay, then we will get the NDVI first. So it looks like this is NDVI have the first function. Okay, let's do it. I think we already did this one. Then we run this one, NDVI. First get the information. So this is the NDVI information for this area, range of interest, and then how to use reduced region and on the mean, reduce, scale, set the day and the format of the mean. Okay, let's just run this first. See what it is. They reduce image and the format call the information, retrieve the data. So this is the day NDVI for each year. So it's the average actually every 16 days looks like every 6, yeah, modis. So modis have every 60 day or every 8 day NDVI product. So this is the every 60 day NDVI product. Okay. And then this is the, I think we did this, right? This. So the NDVI value and then a scale factor of 0.001, because the value in the image is becoming the integer. But if you want to make it to real NDVI value, you need to multiply 0.0001 become the real NDVI value. Then we can plot the NDVI time series from the 2010 to 2021. Okay, so this is the plot. Then you have a big job. So you see before 2018, maybe February, NDVI is much higher than big job, then coming back. So this NDVI change showed there was a big wildfire. I think one student did doing the wildfire study. Who was the one doing the wildfire files?
She's not.
Oh, she's not. Yeah. So I think she can use this NDVI if she would like to use the long-term data set for this data and see the change. Then you can also do a moving average based on this data set. So this is the moving average. Then put a figure. Yeah, so this is the moving average of the 12 months moving average. With the histogram, so is before, so you can make a change comparison before the file, after the file, because the file is this period. With the histogram. And with the info 0.001. Then yeah, so then you see that the NDVI value before, which average like 0.8, after 5 average 0.2. So you can see this is very powerful. You don't need to download any data. You can directly use Google Earth Engine to do this time series. Then you can do the time series of the temperature change, use MODIS data also. So we use temporal change of the surface temperature around the Bale County, which is San Antonio area, use the MODIS land surface temperature data set. Okay. So here it defines the data, the county, the Bale County, which is, you see, you can actually do that. So this is use the data, the county boundary connection from the Tiger County, which is the Bale County is not rectangular, right? Is a county boundary. So you can do that actually, which is then you can also use the field equal, I don't know, equal, yeah, okay. Equal, the land equal to Bale, then you get the county boundary. Okay. Then use the image connection, which is from the MODIS 11A2. Okay, 11A2. I think 11A2 is 8-day average, 8-day average temperature. So let's do one that temperature, get the connection, then do mean, then to reduce imaging, then do the time series. Okay, so this is the temperature, the unit is Kelvin. Yeah, so this is the temperature, time series temperature from 2000 to 2022 maybe, yeah. So realize this one, this is last year, 2021, or lot is a year before last year. 2021, San Antonio had a big snowstorm in San Antonio, or in Texas. So temperature dropped below 270 for a week. So I think this temperature captures actually the lower temperature. Okay. Yeah. So you can do also good. Also good. So I think we stop here. Then in the afternoon, I will ask the student to come to check why this didn't show. Okay. Yeah, I think this one show that. Okay. Any question? Okay. Lucas, Lucas. Ocean. Yeah, yeah, yeah. You can do that. So I can connect you with my student because he know lots of stuff. He can you can talk with me, and so if you have specific question or to get a specific data or specific process, so he can help you. And send me an email. How are you? Good. Okay. So,
No, I was looking at, trying to figure out.
yeah, tomorrow.
Yeah.
Yeah. We ask about Steve, guys.
Change the merchant parameter.
So immediately. So we only have one last left this afternoon. But but that is also very important. We will really use ICESAT-2 data, and also we use the Landsat and Sentinel-2 overlay. So it's two different data sets overlay. Okay.
I'll stop the recording.
Okay.